Lab 5 video. In this lab, we study the behavior of a first-order system consisting of a resistor and a capacitor. The first MATLAB code given is defining this system by means of a Fourier equation and setting different variables such as the time constant. If we run this code, we get this graph representing the voltage out in when the resistor 1 is used, 10 kilo ohms, and the resistor 2. As we see here, there are two ways to get the time constant. One is multiplying R by C, and the other one would be to set the 63% of the voltage that is getting in, which would be around 325, and then seeing what time we get for that value of the voltage. As we see here, we get a time of .1 for the resistor 1 and a time of 1. Those will be our time constants. Moving on to the Arduino code, we first define the variables for the voltage in, then the voltage out, then the time constant we just explained. In the setup, we assign the pins to each variable and wait 5 seconds for the capacitor to discharge. Then on the loop function, we set the voltage in, which is connected to pin 6. We set it high, which is 5 volts, and then we read the value for voltage in and voltage out and get that on a string. We wait a delay of tau divided by 50, which is placed here. We multiply that by 1000 for the microseconds, and then we do this 500 times because we are asked to get a period of 10 tau, and then we do the same here but putting it low. After waiting 5 seconds for the capacitor to discharge, we start to see values appearing on the serial monitor. This would stand for the voltage in and this for the voltage out. The processing code would do two things. First, store the values from the Arduino into an Excel and then plot the values in a graph in a similar way to the oscilloscope. I don't have much time in the video, but I wrote different comments to the main lines to explain what each one was doing. These ones are for the lines, levels for the voltage, and this one for the legend. And this one is just getting the values from Arduino and separating them into variables. If we run the code, we'll see how the values are plotted. The red one will stand for voltage in and the green one for the voltage out. We finish running the processing code. We will see that on our file some documents have been created for each time we have run the code. I've named my document Excel1. Using the second code of MATLAB given, we can plot the values from this Excel in MATLAB. We'll have to set the resistor each time, and since now we're using the 10 kilo ohms, we would put 10. And then here we have to assign the file. As I told you, the file in which our values are stored is named Excel1 for the first resistor. Running this code, we get this result for the first resistor. Repeating the process with the other resistor, we get a different time constant that we change on the Arduino. The processing code won't experience any variations on the code, but we will get some variations on the readings. So this is the result we get for the second resistor. Comparing the two of them, we clearly see that the one for the resistor of 100 kilo ohms has a greater period, time, almost like 10 times the one for 10 kilo ohms.